As mentioned today, our theme is going to be have you got all of the power that you are entitled to? And this comes from several directions. One direction is, as many of you folks know, most transmitters that are current do not have a plate voltage and plate current meter, so you cannot instantly come up with an indirect power level. On the other hand, there is this meter that says power, and now you have to wonder how accurate that is. Has a lot of features, a lot of facets, one being, and I'll turn it to you, Jeff, to start talking, what the load is and how clean that load really is.
So I'm going to correct you on one thing and disagree with you on another. This is how we're going to start the day right there.
All right.
Um, so just about every transmitter built today, while it doesn't have plate voltage and current, will have final voltage and current either as PA volts or B plus or whatever. So you do have volts and current. What you may or may not have is DC efficiency. So, and that's the third piece of the puzzle for calculating indirect power, of course. So now we do provide it on ours. I don't know about everybody else, obviously, but that's one of the things that. And what do they say? A man who has two watches never knows what time it is. Well, somebody who's got two meters never knows what the voltage is, or the power, or anything else, unless they've both been calibrated at the same time and are measuring the exact same spot. And that's something we'll get into quite a bit, especially on FM. Because on AM, it's not a big deal. What's the wave, a quarter wave of 1 megahertz? About 300 feet, give or take. Somebody stick their hand up or yell at me if I'm too far off, but I think I'm in the ballpark.
Mm-hmm.
So if I have a meter 2 or 3 feet from another meter, the reading's going to be pretty darn close, assuming they're both calibrated. In FM, when my wavelength is closer to 10 feet, then that's a bigger deal. And I'll give you an example. Into a dummy load one day, I took a 50-watt exciter. I had 6 bird 43s in a row and running the exciter at 50 watts into a dummy load, which is theoretically relatively flat. Back then, not so much, but close-ish. And I got readings on those watt meters anywhere from, I think the lowest was about 15 to 20 watts and the highest was 150. And I guarantee you that particular exciter was not putting out 150 watts. And there's a bunch of factors in there. And this is where I'm going to grab a screen share and make sure I get the right one and hit the go button. These days I'm getting spoiled, so I've got 3 monitors running and I don't know what anything's doing anymore. But so we do a lot of this stuff with line sections and slugs, sample elements, and then a watt meter. The challenge is, unless they're all calibrated together, you got no idea how they interact. Depending from one frequency to another, from one load to another, you're going to get different readings. So that's one thing that's critical is that you calibrate all the pieces together. Now, for us, one of the things that we tend to do a lot more than that, we do less. Used to be back in the day, this was what we used. We used bird line sections or sometimes coaxial dynamics. By the way, who here's got enough familiarity with the FCC rules to tell me what the tolerance is on a power meter reading? Nobody. I know Grady knows. He just doesn't want to say it out loud. But 3% is what the FCC rules say the tolerance is on a power meter. Now, who wants to tell me what the tolerance is on the average analog meter movement? 5%, exactly. Thanks, Ray. In other words, it's impossible to be compliant right out of the gate. You can't do it. So that's, it's a really interesting conundrum that it's been there since day one. They're asking for a tolerance that a meter won't hit. We've changed things a little bit the way we do it these days, and flick ahead a couple. several. So this is how we do power measurement these days. We're using a power sensor from Bird with their meter and through line section. We don't calibrate it per se. It's all digital. It's a digital. The power sensor does go out for calibration, and you can see we get it calibrated by a company called Pylon that lives 45 miles or minute drive from us, so that's convenient. But the power sensor and the through line section we characterize with a network analyzer, which is calibrated annually. And assuming that the characteristics haven't changed, then we're good to go. So that's one way that we've changed this a lot. And I say we, the industry as a whole, not just we at Nautel. Now, going back though to the through line section, this is what you're looking at with the through line section. So you've got your through line, you've got a capacitive coupler, and then you've got your slug to basically voltage divide it down and give you a sample to the meter. Challenge becomes that through line section right off the bat is several inches, so it's going to add 3 or 4 degrees of phase rotation. If you've got any nonlinearity in your load, then from point A to point B, you're going to get different meter readings. So this is why the one of the things that the FCC has always said was meter readings have to be done at the output of the transmitter, because 2 feet away from the output of the transmitter, you could get something totally different. Let's see, Ray mentions using slotted lines, yep, for precision SWR measurements. And same deal with sampling along the transmission line. So what you did those days, Ray, if I'm not wrong on it, but with the slotted lines, you took multiple samples and averaged and ended up with a pretty accurate reading that way. And you know, if I'm wrong, holler at me, but that's as I recall, and that goes back, yeah, more than a year or two. And that is one of the things that you can do. One of the other things you need to do is when you get your directional coupler and you get it calibrated at Bird or wherever, you need to have correction curves. Because as you can see with this one, at 40 megahertz, you're going to get a much different result than at 400 megahertz. Now, within the broadcast band, it should be fairly flat, but that's going to depend on your load as well. So thoughts, comments, questions as I go, just holler out or interrupt me, because I'll sit here and babble along. We all know this. And like I say, I see, oh, Phil's on. Good deal. Hey, Phil. But anyway, so that's one of the things that is kind of a big deal. Like I said, a lot of that stuff gets not eliminated, but reduced. I've had situations, I had a guy a bunch of years ago called me up and said, my base current meter reads this. And I said, okay. And he goes, but I should have that. And I said, wait a second. So it's reading 26 amps and you think you should have 31.3. And when was the last time your meter was calibrated? Oh, it's never been calibrated. Then I'm going to probably put a lot more faith in the transmitter metering that was calibrated 3 months ago. So, but he wanted me to teach or tell him how to adjust the transmitter meter to read what it matches base current. He didn't care about it being right. He just wanted the numbers to be the same. So that's another interesting conundrum. And I've run into that once with one of the bigger antenna companies that makes or made at one point a metering system. And we'd sent it out to a customer. They bought it through us, and he had an issue where it didn't agree with other things. And they said, "Oh, well, just go in and adjust this." And he goes, "So you're asking me to break calibration and just make it match this other meter?" Yeah, that's how we set them up in the field.
Of course, now you're talking with AM. Now we have to talk about the base impedance or the common point impedance, and then to your lightning choke.
Well, and so theoretically, your lightning choke shouldn't affect impedance a whole lot. That depends on, but yeah, you need that in place. I mean, common point impedance is pretty easy to do because you're in the phaser, you're already all your lightning stuff is accounted for. So directionals in that regard are probably, I say easier, they're not because you ever see a flat directional?
I don't believe so.
Not many. That, whereas a single stick, you can tend to get it a lot broader band. But yeah, you've got to do that. The challenge there becomes if you're not exactly J0, then as you rotate through the coax going back to the transmitter, you are going to have some differences in readings. So, less so with a current meter than with a power meter, but still some.
Well, do you want to talk AM or do you want us to go back to FM?
I'm jumping all over the place. We're talking about both as long as
All right,
we're
let's
going.
let's start with AM then. So let's say you have a kilowatt AM into a
Mhm.
non-directional stick,
Okay.
and that particular stick is licensed at a particular impedance,
Hmm.
but you don't know that that is the actual impedance.
Well, and that's number one, like I said, with sweeping the loads for the FM. If you haven't bridged your load to know what the impedance is, then right off the bat, you've got no way of verifying how accurate your readings are.
A lot of small stations don't have a bridge. They don't,
The-
all they can do is guess.
And legally, you can't guess. Legally, you need to get somebody in with a bridge. If you don't know what you're loading into, you can't do it.
So when your transmitter,
Hmm.
I say your transmitter in the generic sense,
Oh
says
no,
what,
they're all my transmitter. You guys just pay a lot of money for the right to use them.
oh, okay. So it says 1 kilowatt on the meter, the output meter.
Sure.
Now, we don't know unless we have a bridge and a sweep. We
So
don't know what that really is, do we?
if, and there's the big if that transmitter is looking at exactly 50 ohms, J0, then we can rely on that 1 kilowatt. If you, for example, have a really crap ground system and it runs between 40 ohms in a wet day and 60 ohms on a dry day, then you don't have a clue how much power you're putting out. And it's one of the cues you'll see in that is if it gets to be a wet day where the resistance is up and the voltage tends to go up and the current tends to go down, you'll start getting modulation shutbacks. It'll transmitter will think it's overmodding.
So let's
So
so let's take that case.
yeah,
Now, there's two
and
aspects.
that's a real life case on a hill in Tennessee because this is where I got those numbers from.
Okay, so let's take that case here. Now, how would the operator know that the meter cannot be relied upon, and how would he calculate an indirect power at that point?
So theoretically, if you do your PA volts and current times whatever the factory told you the DC efficiency was, and I mean, and again, we may not have a measured efficiency. I can tell you that any of our 1 kilowatts, pretty much back to the AMFET series, are going to be 75% DC efficient, plus or minus a percent or two. And as we already determined between the FCC requirement and the average analog meter tolerance, if we're within a percent or two, we're going to be doing pretty darn good relative to what we would have with a analog movement anyway. So if I take the volts, the current, multiply by 75% with the modulation shut off,
What
because
voltage and what current?
PA volts, PA current in our transmitters. Now you're making the blank face. On the J1000, the 1 kilowatt transmitter, there is a reading for PA volts and one for PA current. And if you take those, multiply them, and multiply that by 0.75, you should come very close to the power reading.
Do all the Nautel AMs have that voltage and current?
The AMFET series used mod IP volts and total current. The ND1 used B minus VDC and total current. So they name it something different each time, but yeah, it's there on all of them.
Okay.
And let's see, the AMFET did not remote those. The ND and the J1000 do remote them, so you can read them on a remote control as well.
I've seen other transmitter manufacturers where, let's say there's 8 modules, and
Hmm.
each module has a different number of amps and volts.
So there's only one transmitter manufacturer that has independently metered modules, and that's not us. Well, no, it
No.
is us because the old AMFETs had individual, but they also had a total reading as well.
So
But
you could specify that. You could check your test data from
yep,
the transmitter from the factory and make sure that not just the output meter says 1 kilowatt or 5 kilowatts or whatever, but that the voltage and the current continue to be in the same place.
right. I am going to flick off the slideshow for a sec, and because I am a terrible uh, Facebook
While
Facebook
he's doing
user.
that, I'll mention,
Yeah,
folks, if you want to ask a question, raise your hand, click on raise hand, or put it in the chat box, and we will pass it on to Jeff.
I'm going to spell Harold's name incredibly terribly wrong, but it always gets me there anyway. Let's see. Yeah, and say feel free to open the mics too. David, you're being uncharacteristically quiet today. Is something wrong?
Oh, yeah.
Oh yeah, something's wrong.
Your voice sounds better, David.
Thank you for noticing. The eyes stopped being beet red, too. That was a great step. A lot of this for the AM, it's a question of what do you want to be worried about? And our concern about the accuracy of meters strikes me as one of the, it's so minor, I don't worry about it. The thing to look for is when the numbers you have on installation day, when kind of everything is working, when it changes. At the point your direct and indirect start to disagree, this would look like a problem, but yeah, it could be meter drift. This
Yeah.
is the place to have a dummy load and say, okay, is the transmitter pretty happy into the dummy load, less so into the antenna or the phaser? And most stations don't have they don't have people concerned enough, interested enough, or capable enough to do that.
And that kind of comes back to where Barry's like, if you don't have the ability to bridge the antenna system, it's like, well, if you don't have the ability to bridge the antenna system, you either need to get the ability or you contract it out to somebody who does have the ability. Because if you don't know what your load is right off the bat, you're technically not in compliance with your license, or you
That's
may not be, and you got no way of knowing.
and you have no way to know. And that's back to, was it working once? Was
Yeah,
all this was this all checked when you installed it? And if that day was yesterday, I'm not very concerned. Absent the lightning hit, and
right.
with enough ferrites and enough grounding properly laid out, that
And
I
I
can't
mean,
remember the last time I had a lightning problem on something. It's some places the stories, the problems people have. I think, wow, I live a very dull life because so many of these problems we don't have.
it's amazing what good grounding does for a difference. But that's a whole different discussion too.
But it's when you
I
slide off of, you know, it was working correctly. It's kind of like when you're driving. This
mhm.
is a clear road. There is no ice. Nothing is wrong. The road gets slippery. You expect different results from the car. You'd sit there and say, huh, my RPM and a gear ratio don't get me to the highway speed that I had before. It was, now I'm slipping. I'm losing power somewhere. And that's the same as your direct and indirect disagreeing. But
Yep.
you kind of know you're skidding. You know that you're driving in sand, you're driving in snow. Um, the hurricane brought water where there was no water.
Right. And I mean, it's like if you had all this stuff, or you had your bridge was swept or your antenna was swept, and you know exactly what the impedance is and you know what the current should be, and the current's been there and the transmitter power's been agreeing with it, and then all of a sudden they don't, then something changed. But if you put in a new transmitter right off the bat, something changed. So you got to worry about that.
There's another factor too, and that is if you come in and you're hired to a station that's already been on the air, and
Something
you want to
changed.
know
Yep.
where you are and what came before. And I can only tell you from my own personal experience, a lot of guys have never maintained a maintenance log or
Oh.
in any shape or form that you could
Yep.
follow.
We had this discussion earlier on, I think it was a broadcast engineers list, but it could have been any one of them, where somebody was talking about the spit and baling wire, and I said I've seen a lot of sites put together with like that, but if I walk in and a modulation transformer for 50 kilowatt is sitting out of the transmitter on 2x4s, I'm out of there. You know, I mean there's been freedoms taken that I'm not willing to be a part of. So, and the reason I went to Harold's site, did that show up on the screen? Did that screen still sharing?
No.
No.
No, that figures. Let me get back over here. Share screen and there. And share. Should be now.
Yep.
All right. So I brought up 73-267 because it very specifically applies. And one of the things that applies is paragraph C, subsection 1, where if the manufacturer doesn't give you DC input and input current and voltage to the final stage, and again, final stage being in a solid state transmitter, the filter, then if they can't give you volts, current, and efficiency, then they're supposed to give you some other formula to achieve output or to measure output power. Now, one of the cool things in 1980, I've still got a copy. I think I might have the original buried in my desk somewhere. A letter from Charles M. Cobb, who was head of the Media Bureau. That might have been 81. But specifying that the power metering in our AM AMFET series transmitters was type accepted for indirect reading. And that's funny because if you look at the requirement for direct versus indirect, our metering looks at voltage, current, and phase, which achieves all of the requirements for direct reading for what that's worth. Now, you know, having said that one way or the other, again, they're asking for a 3% tolerant, or let's see, electrical device within 5% accuracy now, and coolant flow indicator on a calorimeter 4%. So that's changed because it used to be 3, I'm pretty sure, but 5% good. Now we're within meter tolerances anyway. So, you know, that is one thing that that we really, really don't touch on enough, because if you don't know your load impedance, then all of this stuff is going to, I mean, I can tell you what the transmitter's producing, but I've got no idea how much of that is going to the antenna. You know what I mean? So you need to have the load impedance, and if you don't have a bridge, then you need to hire somebody to bridge it, and then you're good to go. And yeah, not doing so is not an option. I mean, the transmitter meter will only get you so far if it doesn't know what impedance it's running into.
And you need to resist the temptation to adjust that power output meter just based on what you're looking at a given moment.
Yup. That one happens so much more than I'd like to I guess it not admit to, because I'm not the one doing the adjusting, but we get asked that question almost monthly. And even on FMs, like I say, we've had a lot of FMs where the power, they've got maybe a Model 43 or a through line watt meter, a line section right after the transmitter somewhere. Somewhere it could be anywhere between right after and 20 feet away. And it reads significantly different because there's some reflected power coming back. And so, of course, it's going to read different because you're going through the phase rotations in the coax. So you hit voltage and current peaks and nulls as you go, and bad things happen. So yeah, unless you've got 2 meters, even immediately adjacent, as I said with my little test with the exciter, they're not going to read identically. And unless you put a meter line section and stuff in, take a reading, take it out, put the other one in, take a reading, take it out. That's the only way. Or you measure exactly 180 degrees away. So you put them every half wavelength apart, they should be bang on with each other.
I think one of the questions that again, raising when you come into a situation that you were hired for and it was put up by somebody else, maybe you're just a contractor, and the question, becomes what the original parameters were. In the old days, you would not only have tubes that would go soft so that certain voltage and current would only result in a certain power output that might not be normal, but also those thermocouple meters. And I remember coming into one station and finding that the meter was off by 15%, was low. Station got a real nice boost in power out of the deal when I fixed that. But you need to have good documentation. We talked about this in the past, not just for yourself, but for whoever comes after you.
Yep. And it's funny that Tim mentions in here regarding the PA efficiency factor, use your factory test data sheet to calculate the PA, the efficiency. And that's great if you get a test data sheet. If you're inheriting a site, I can guarantee that factory data has almost always grown legs and walked away. These days on new transmitters, we bulk test them. We create data sheets for each of them, but we don't ship them with the transmitter. You have to request them. And I can tell you that I can count on one hand the number of requests we get a year. So yeah, absolutely. I mean, it's a good thing to have. Now, the other thing too, with our current transmitters, we display the efficiency on the front panel because the transmitter is dynamically calculating volts and current and output power and giving you the number for efficiency at any given time. And that, oh, by the way, that's something else that I forgot earlier. Efficiency changes. So if your 10 kilowatt transmitter is tested at 10 kilowatts, that efficiency won't be the same as if you're running it at 5 kilowatts. So unless it's been tested at the power level that the efficiency was noted for, it could be off by, on a tube rig, a lot. On a solid state rig, 5% from full power to half power for some models. It's so absolutely, what do they say? Trust but verify. You don't know that number is going to be accurate.
Of course.
Now, I talked to our Charles Andrews, our test supervisor this morning, because like I said, when I worked in tests 33 years ago and change, we used current meters, just regular old current meters for measuring the RF current, and we measured the RF voltage with 400Es and big old attenuators, and then we swept the loads and we calculated everything that way. Then we leapt into the 90s, quite literally in the 90s, and started using calorimeters, which are obviously much more accurate. And then in the FM, it was mostly directional couplers, and we just calibrated the couplers against the calorimeter every 6 months or so. And now with these power sensors, so and it's funny because Ray had mentioned the Keysight gear, and that's one of the things that we use. But so our Bird gear is calibrated against the Keysight. The sensor's calibrated. For low power, it just all gets calibrated. And the big thing that we've been beating the drum on, we sweep all of our loads every 4 months. Because amazingly, resistors change value, especially when you make them turn cherry red on a regular basis. But that's a whole different discussion.
And let the magic smoke out.
I like to take them just to the point of smoke. But and that's something else. Like I said, we sweep the loads every 4 months, and every time we do, there's a correction curve put on the load. So, I mean, it's, we're going way back in time, and rather than storing that stuff electronically, we just print it and tape it right to the side of the load so it's easier to see. But yeah, we can tell you within any given time what the nominal return loss is on any of the loads. So that's just one of those other cool things that makes it easier to get it accurate going out the door. And I think that's the thing. Anytime you get a new transmitter, and I don't care whether it's us, Gates Air, BE, LNOS, whoever, if the power meter on the transmitter doesn't match what you're seeing on your through line meter that hasn't been calibrated in 20 years, don't call the factory and tell them their transmitter's not working right. Not first, anyway.
No, you have to make sure you've got the right load, and again, you mentioned dummy loads. Just like auxiliary transmitters, a lot of places don't bother with dummy loads anymore.
Nope. And that goes back a lot of years. I mean, I can't tell you how many 5 kilowatts I've gone out to do field work in where the only load was a cantenna.
Mm-hmm.
Which is great as long as you got a fresh load of linseed oil in it.
I think that was value engineering when Harris decided to take the dummies out of their transmitters, and Collins Continental, same sort of thing.
It's part that, and yeah, I mean, obviously you're going to reduce the cost anywhere you can. Like the J1000, we ship those with a reject load for if a power module fails, and in a pinch, those could be used as a dummy load for something else.
Mm-hmm.
Although if you had a power amp failure or things went down and came back up, then that reject load being missing would be a very big issue very quickly. So I wouldn't recommend it. But yeah.
Okay, let's switch gears for just a moment, and I'll raise another question, and then I'll sort of fade here and see if any of the folks have some questions for you. Modulation. Can you trust the modulation meter on the transmitter? And if so, why?
You should be able to. And I mean, again, I'm talking about ours. Now, I'm going to qualify it. And let's see, since I am on a roll with opening other stuff up here, I'm going to see if I can scoot down. We're trying to make, there we go, trying to make things adjust when I want them to is never the same. But I'm going to log into a 1 kilowatt just up the road from here, because this is, it's an on-air transmitter. It's my, not with our VPN, I'm not going to, but it's my go-to for showing stuff like this and explaining it. VNC. Yeah, I know VNC is not the preferred way of doing this sort of thing, but it's what we've got to work with. All right. In a second, I'll get this dragged onto a different screen and share it. Alrighty, get that there, and sorry, it took me a little longer to type the password because we don't use the plain old default password.
You don't use default passwords?
I know, right?
Jeff.
What a novel concept. All right, so at this point, you should be looking at the AUI for Cove FM about half an hour away from me in Hubbard's, and you can see the modulation meter. And you can see it's running, peaking at 107, 108, give or take, which is actually kind of low. And this is why I bring up when you ask, can you trust the modulation meter? The answer is yes, but. Yes, but we're running, let's see, let me open the baseband up. So we're running RDS at 5% injection. So right off the bat, that means that I'm allowed 2.5% of that, or half of it, onto my modulation. So that sets my top to 102.5. We're running stereo with 9% injection. So now my peak is 111.5. So if I look at this meter and I'm tapping 111.5, I'm bang on where I should be. If I'm over that, then I'm over modulating. Is it accurate? Yeah, it's accurate to a calorimeter level. Now, well, let's put it this way. It will be as accurate as any analog modulation meter you're going to find out there. Except maybe a properly calibrated QEI 695 that nobody's ever breathed on. So anyway, that's the short answer for that. The mod meter is accurate, but you will notice too that the reflected power is drifting quite a bit. So I can tell you flat out that my forward power reading is off by almost 45 watts. We're putting out about 1200 watts on this guy. And I know that because somebody stepped on one of the antenna bays in the process of doing some tower work. And so we're not looking into a 50 ohm load, and we have swept it. So, you know, is what it is. We'll deal with that when the new antenna goes up this summer. All right, questions, comments, thoughts? Rich is practicing for next week. I see him chewing his tobacco over there. I never thought I should. I don't think we've got the VS1 connected here at the moment. Let's take a peek. I think it was
Is that half of your stereo carrier? Is that's in Canada? I don't know that that's true in the US.
I believe you will find that any SCA, and RDS is an SCA, a subcarrier, you can reclaim half of it up to a total of 5%. If anybody, I'm going to say I may be wrong on that. So if I'm wrong, somebody point it out and yell at me. Because all I'm seeing is blank faces. If I'm right, somebody let me know that too.
Was Barry's question, did that apply to the stereo subcarriers? Because they don't. It's just the RDS and the stuff above
right
50 odd kilohertz.
So you can reclaim half of your
yes.
Yeah. So you can reclaim half your SCA injection.
Yep.
Your RDS.
Although so I had this argument with a Phillips chief station in El Paso, and he said, nope, I run 104.5 because I have 9% stereo pilot. And I'm like, not what the rule says.
Right. And I mean, for us, like I said, I know I can claim half of my 5% RDS injection. I know that my pilot is shown on my mod monitor. So I allow for the pilot when I'm looking, because 109 is 100%, just because of the way this mod monitor is configured. And then I add 2.5 for the half of the RDS, and there you go. So that's how I set my top end. Although my modulation meter would show me, you know, if I was trying to reclaim all of the 5%, it'd show me 114 on a peak.
Yeah, the thing we usually measure is just take the occupied bandwidth from the spectrum analyzer, which takes a longer integration time. Right. But that's your interfering potential in occupied bandwidth rather than the peaks of these various. The SCA doesn't wander much, the RDS hardly at all.
Right. So that's, you know, let's see. Oh, David's mentioned, you mentioned here about the cantenna. Oh, out of a 1 gallon can into a 5 gallon bucket, that would have been a much more power.
I discovered this, their contract chief and I had fixed one of his stations. We head over to this site and it looked like a smoke machine. You open the door and there's fog pouring out. It's smoke, but it's, I discovered, so that's how the fog machine works. And I thought it was very serious. And I get to the back and there is this, just the resistor and the connector from a antenna stuck in a much larger can. And it's just bubbling around the connector. The oil just has little bubbles like, oh, we're about to pour the French fries in. It'll be great.
Yeah. And I mean, I walked into a site in a country with a lot of sand and high temperatures not too long ago. When I say not too long ago, I mean, I've been doing this for a lot of years. So it was like 2000. So not too long ago, almost 25 years ago, but it was just yesterday in my head.
I get that.
And anyway, so I walk into this site, and okay, that's it. The fourth be with you is all the way here now. I'm officially done. Colin's got the screen for the rest of the day, but so I'm not even going to be able to finish my thought anymore. But I walked into this site, and they were putting up 100 kilowatt, and we've got they built their own dummy load. And we're questioning, and they're like, no, it's good. It's good for 100. Okay, fine. So we start bringing the transmitter up. We get it up to 10 kilowatts, 20 kilowatts, 50 kilowatts. Everything's good. Crank it up to 100. And I start smelling something. You know, that kind of crispy, singy smell that you get. And I told the guy I was with, I said, can you want to go back and take a look at the dummy load? And he walks around the transmitter and through the door into the back room and then around into the dummy load. And all of a sudden I hear, turn it off. And he comes flying back. So I hit the off button, and we wander around back, and there's flames shooting 8 feet out the top of this dummy load. We set the paint on fire. It was spectacular.
I was going to say, I'm surprised he didn't yell fire.
I'm not 100% sure why he didn't, but anyway, it all got the message got passed quite well. You know, the panic sound usually means reach for the red button. So, but yeah, I mean, so this guy, like I say, this is Cove, and mod meter. I can tell you that modulation meter, once I factor the pilot and the RDS, will be bang on with the TFT or a Bell R. Now Barry's thinking of other questions. You're muted, Barry. There you go.
I'm just reacting to TFT accuracy.
Well, it's all relative. Any meter's as good as the last time it was calibrated.
Nothing TFT has been calibrated in a decade now.
It's been a while. It's been a while.
Well, not at the factory anyway.
Right. And I mean,
but that's true of so much in the industry. We have lots of discontinued lines and orphaned equipment.
Right. And I mean, it really doesn't matter what industry you're in. That's true pretty much globally. I mean, companies come, they live, they die, they go away, whatever. But you can still find people to calibrate those. I think, so for TFT, I know Mike Patton was doing some. Is J Squared still doing them?
Yes, but you have to spend money to do that.
This is radio. If you're not spending money, you're not doing it right. Well, business in general, you know, I mean, you can't, again, I'm not even trying to advocate for the people that won't invest the money to properly bridge the load or calibrate their test gear, you know, because at that point, you can't, what do they say? You can't teach a Heinz pickle nothing. So, you know, I mean, I can't think of another way to put it. You got to have your gear calibrated, or it's not accurate and you don't know it.
Mm-hmm.
So, and the same's true of multimeters. You know, I mean, we get ours calibrated on I think, annual basis for most of them, but it'll depend too how much you use it and how much it costs to get it calibrated to some extent. But if you've got like a GR radio bridge that's never ever been calibrated, that thing's not going to be accurate anymore. You know, can it be made accurate? Oh, absolutely. Those things are tanks. I mean, it's, you know, the old, what was the Potomac, the one I blew the front end out of in the 50 kilowatt site. Discovered that it didn't like to be set to the 10 microvolt per meter frequency on the 50 kilowatt site. It made a squealing sound.
Whoops.
Yeah, but no, that was a FM41, I think. So anyway, you know, again, that stuff, your test gear needs to be calibrated. There's no way around that.
Well, it really should be part of the maintenance protocol for any particular station or station group.
No,
No question.
maintenance protocol, that's almost like political intelligence.
Thank you, Jeff.
I had to get one dad joke in there. But yeah, I mean, there really should be a schedule for calibration. And, most of it you can only go by recommendations from the equipment manufacturer, whatever it may be. And then from there, you're going to adjust it based on your own particular situation. If you've got, well, an example, if we've got an analyzer that's not being used in the field, so it's always sitting on a rolling cart, rolling here to there and getting connected, and nobody does anything stupid like trying to connect it directly to 50,000 watts, then that one might go on a 2-year calibration schedule. If I've got an Anritsu SiteMaster that is constantly getting thrown in laptop bags and suitcases and into the bellies of airplanes and all over, well, not in the belly of an airplane anymore because they don't like to see those batteries underneath. But, that sort of stuff, that will probably go on a 6-month cal schedule. So it really does depend on what you're using and how you're using. Old Cantenas use transformer oil with PCBs, so did the coffee. Hey, radio station coffee is a PCB substance.
Now I'll circle back to a comment I made earlier, and that is that, and I think you mentioned it as well, the exact power output of a transmitter. Now, David mentioned this, isn't exactly something to lose sleep over, because your coverage pattern is
No.
not going to vary that much. And
Well, and the FCC allows +5, -10. So,
Right.
if you're within 1% or 2, you're
And-
close enough.
And all of that range is not 1 dB of coverage difference,
Not
no,
even. No.
because
But
it'd be
you-
the square root of the 15% difference. And it's the thickness of the line on the map.
but I have
Mhm.
seen stations where they intentionally run the power at 104.5%.
To that, Harold,
Oh, yeah.
Harold wrote the articles for Radio World where he said, look, here's the window at the commission. Here's the window on your meter accuracy. And he posited that to stay within the +5, -10 range, you had to be not just in the dead center at 97.5% power. He said 97.5% wouldn't guarantee your meters weren't putting you too low or too high. He said, okay, we've just, thought exercised our way, to another impossibility. And I've known people who thought 98% just said at the middle of the scale, it improves your chances of being right.
And these days, with like things like that power meter that I was shown before, the Bird digital power sampler, I mean, we lose a lot of the inaccuracy of an analog meter movement. So we're able to get the accuracy pretty much calorimeter accurate, like within 1 to 1.5%.
Yeah, the
But-
numbers, the machines that Bob Tarcio makes have
Right.
a compensation scale
Mhm.
built within them.
Yep. And I mean, those things are bang on. Now, having said that, once your load impedance goes off the nominal load impedance, all bets are off on whether the meter reading's accurate or not.
And that includes not just AM, but FM as well, because
Oh, yeah.
as antennas age or take a lightning hit or a bullet from the neighbor,
Or the power company's contract guy steps on your lower bay, and now you're not looking at a 50 ohm load anymore. Or you're looking at a 50 ohm load, but with some J that is not 0 or anywhere near it, then yeah, yep, that'll happen.
yeah. And that's why it's important to regularly check these things and make sure that you have what you should have and that the numbers are routine.
Right. And I mean, for us, like I say, we're replacing the 6814 with a Versatune, and it's not really because we couldn't fix the 6814. We absolutely could. But the Versatune's got much better bandwidth, and our tower is overloaded to the point that I can't put radomes on it. And I'd rather have something that would handle a little more ice before it shuts things down.
Mm-hmm. I
So-
think I think the whole topic of antenna maintenance for FM is something that most people, well, that's 400, 800, 1,500 feet up there. What am I going to do? And we had a nice discussion with Tom Silliman about that, and why you need to pay attention, and Gary Minker talking about the need to run a TDR from time to time.
Yep. Yep. And I mean, same deal, you know, if you, and we did one of our TTT sessions on that, be about a year ago now, I think, maybe even a year and a half, where I had Todd Loney from our RFS then, and Pete, forget Pete's last name now, tower guy out of Texas. And that's one of the things they were talking about, was that you need to sweep this stuff on a regular basis. Number one, you sweep it the first time you can, and then you get your reference, and then you look for what's changed. It's like we were saying earlier, if I plug a new transmitter in and I get all my readings and everything's golden, then after that, I just look for it to change, which, you know, kind of impresses on us the need to have the jocks actually writing the numbers down instead of just writing last reading's set of numbers down beside them. Not that that ever happened.
You know, in Boston, we had the first RCA circular polarized antenna, RCA had unity gain up about 1,200 feet. I got a call one night from a listener saying, "There's a fire on your tower. One of the bays caught fire." We had to call a crew in, of course.
That's a fun call to get.
Yes.
So these days, of course, you'd have 15 staff members gathered around the base of the tower with cell phones putting stuff on TikTok right away. Because if you can't broadcast, you might as well be streaming the social media aspect of it anyway.
But we were still on the air. I don't
Mhm.
remember what the meter readings were at the time, but we were still on. And I didn't notice
wa-
anything until I got the call.
I watched a antenna burn 2 bays out of an 8 bay right straight to the ground, and the transmitter stayed on at full power.
Mhm.
Just because it happened to be the right fraction of a wavelength away, the transmitter didn't see the load go to crap.
Well, there was a story of some guy that walked out of his transmitter shack, and there was molten plastic falling all around him, and it was the radomes on his antenna that were on fire, that were melting.
Mm-hmm. That stuff will get your attention.
Well,
Wonder how well plasma actually radiates RF though.
Good, but it radiates on all the frequencies. Sort of like an old Crown transmitter that hasn't been recapped in a while, but that's a whole different discussion.
No, I can understand from an engineering perspective, you know, that you'd want to know exactly what your equipment is doing. But does the commission really care?
Anymore? No.
No.
I said that out loud. I rephrase that. I think they care. I don't think they have the ability to monitor or enforce like they used to. So I think primarily, unless there's a complaint. Now, having said that, if anybody in the neighborhood has got a bone to pick and has any inkling of it, then absolutely they'll make the call, and then you'll be getting a visit.
Mhm. Well, I had that happen in, let's see, just outside of Washington, with an AM that went from 1 kilowatt to 50.
You lit up toasters all over the neighborhood.
Oh, yeah. We actually had some politicians getting involved because the neighborhood was really up in arms.
Mm-hmm. I got a call from an FM in not too far outside of DC once, and they brought me in with a spectrum analyzer to verify that, basically do a proof on the radiated power to prove that they were not radiating the harmonics, but that the fundamental was overriding because they'd gotten a power increase, and somebody's karaoke machine was being affected, turned it into a radio station. And apparently this somebody was politically connected and in that part of the world, can't imagine. I'd make the argument that the radio station was probably broadcasting better music than anything that would normally come out of the average karaoke machine. But
Well,
you know,
this was talk.
again, I stand by my statement. Have you been to too many karaoke parties?
And
All right, well, I'm getting close to having to wrap it up for the day because the real boss's car is in the service center up the road, and they're going to expect to want to go home at some point. So
let's
I
just
will-
remember to be courteous to those vegan runners.
I'm here to tell you that I am not putting my charcoal grill in my living room just to satisfy the vegetarian that doesn't want to smell meat cooking when they run by. But I will cheerfully throw another steak on it for them. All right. On that note, I'm going to say goodbye, everybody. But thanks very much for having me again.
Well, Jeff, as always, we're glad to have you and your viewpoint on so many of these things you've seen over the years, and help us to answer questions about Nautel stuff in particular.
Stuff in general, just stuff. I have
Stuff.
opinions on almost everything, and I'm not afraid to share them at this point in life, which is kind of scary for the next 20 years. All right. We'll see y'all later.
You have a good one. Take care.
Bye now.